Yeah, let me continue with the map. So if we review a little bit about the map and dictionaries, in Python, we have a specific class. We call it the dictionary class. So the dictionary class in Python represent the data structure of map. So last time we learned about the map entity. If you use the dictionary in Python, there might be also the similar syntax like this one. So last time we already learned those. Okay. Now let's see this example. If you have a map or dictionary, sometimes we call it, this is dictionary in Python, but in many times we call it map. Like in other programming language, let's say Java, we call it map. And as you know, in the dictionary, you will use the curly bracket to represent set or to represent dictionary. Now let's suppose the first is empty. And then the length of the M is empty. This is 0. Now I want to make one element. So I want to create a new key, which is K, and the value is 2. So the information that will be given to the map is K, which is the key, and then 2, which is the value. Okay, so this is the value. Now, we have another key, which is P, and the value is 4. Then we will add another element, which is key and value. However, this is not in order. So it is not in the good order. It's not in a sequence. Because in map, there will be no sequence. So this sequence, we can say it is like just a coincidence. I put it K and then P, okay, and then U and then P. Okay. But actually there is no order. And I want to put U with the value 2, U and the value 2. I put the value V and the, I put the key V and then the value 8. I put the key V and the value 8. So we have like this one. Now I'm going to change the value of K. The original K is 2. Now I want to change the value into 9. Then I change K and the new value is 9. If I want to check what is the value of P, we know P equals to 4. Then I will show 4. I want to check what is the value of X. Is there any X? No X. Then there will be a message about error. And if I want to get F, so what is get? It is the same with the previous one, but I want to see the value of F. And we do not have any key equals to F. Then the result will be none. I want to get F, comma 5. Is there any F? There is no F. But I give the value 5 here, if we cannot find f, then the return value will be what we define in this map. Maybe it's better for me to make the let me make with a different color. So this 5 is from the value that I put on the syntax. Okay. Now I want to get k comma 5. What is k? K is having a value of 9. So the value is not 5. Then it will return according to the value that has been assigned to the k. So we have the value 9. What about the length? The current length is 4. Okay. We have 4 items. 1, 2, 3, and 4. How about if I want to delete MV? V will be deleted. V will be deleted, and there will be the written value will be just blank. And then I can do also pop. Okay. So delete means I'm just removing from the existing dictionary or from the existing map. But if I do pop, it is almost similar with the stack, push and pop. Okay. So I want to remove. But which one that I want to remove? Yeah, I'm using this one. The parameter equals to k. So I want to remove k. K will be removed and we will return the value, which is 9. If I want to check keys, then I want to return the values for all the keys that exist in the dictionary. So we have P and U. What about the values? I will return all the values that exist in the dictionary, which is 4 and 2. If I want to check the items, then I will get all the keys and value. If I'm going to set default, what is the meaning by set default? I'm going to put B and I want to check whether B exists or not. If B exists, then forget this value because B already exists, and let B just using the current value. But if, for example, this one, A, comma 1, and use the set default, is there any A? We cannot find A in this data. So we will put A and then we put the value that has been assigned here. So we will put 1 as the return value. If we do pop item, in the previous one, we have pop k. I want to pop or I want to remove the key equals to k. But in the pop item, it will be random. So I do not know which key value that I want to remove. So this one is totally random. Okay. So this is the syntax or the mechanism from the previous part that we already learned. So those are the things that we already learned, and this is the example. In the map, we can apply a simple list-based map. It means I can put the elements of map, which is key and value, into a list. Do you know what is list? Okay. In Python, we know what list. So in the list, you have only one element. Okay. But now we are going to make a list, and as you might know, when we learn lists, there are several kind of lists. We can have singly linked lists, doubly linked lists, or just a common list. There will be kind of other lists like array lists and so on. And let's say I'm going to implement with the unsorted list. I'm not sure if you still remember. Last week we learned about the unsorted sequence in the priority sequence. So we have the unsorted list, and we can store the items of the map in a list S. And let's say this is based on the doubly linked list, and we can put it in arbitrary order. In the doubly linked list, we have header, we have trailer, and for every element of the list, we will have the key and value. So it is not only one value like what we learned on the doubly linked list, but now we have the key value, and key value for every of the nodes. And we assume that this value has link to another node. This value has link on another node. We can apply with the doubly linked list for this map. And if you want to learn more about the maps, actually there are many parts of the map. I think in the next slide, we learn about the map base. And for the map itself, there will be a lot of variants. We can have unsorted table map, and we can learn about hash map, or we can use the sorted table map. We can have tree map. I will not explain all. Okay. I'm going to focus on the map base, and then we are going to learn about hash map. And in the hash map, we will learn about chain and probe. So in the next section, we will learn about this chain and probe. This is the map base. You already learned all the functions that we have. Let's say this is the constructor. And the constructor contains of key and values. And then we can check whether the equality of what you want to put in the parameter with the key in the map. And then we have also not equal, less than. This is an example of the unsorted table map. So you can define the constructor, and you can define the get item, how you want to get the item, and then you can set the item, which is the key and value, and then you can delete the item, and then you can check how about the length of the items, and then how if I want to check for every element in the map. I mentioned about the unsorted list. So this is implemented with the unsorted table map. If we use the list-based map, the performance is, when we insert an item, it will take O1 time, since we can insert the new item at the beginning or at the end of the unsorted list. As I mentioned to you, in the map, we do not care the sequence. That's why we use unsorted list. If we do care the sequence, if I want to know which one is the first, which one is the second, then I need to use the sorted list. But in this case, I do not care the sequence. So I can just use this unsorted list. If I use the unsorted list, it means every time I insert, it will take O1. I can insert in the beginning, I can insert at the end, and it is only one operation. However, if we want to search or we want to remove, it will take ON, because we will check one by one. And it is the worst case. The worst case is the item is not found, and we traverse the entire list to look for an item with the given key. The unsorted list implementation is effective only for maps with small size, or for maps in which insertion are the most common operations, while search and removals are rarely performed. So, for example, here historical records of login to workstations. So let's say I want to know if you access the university e-class. So if it is only to capture or record all your login operation, then you can use map. Because maybe I will not search too much about your login information. If it is necessary, then I can search. Or if I need to remove your login information, then I can search. But it is very rare. So you can use map for that purpose. Okay, that's about the map. And now I'm going to explain the one section, which is about the hash. In this slide, I'm going to explain about hash tables. The key idea of this hash tables, I will explain about the basic definition, and you will learn about the hash function and hash tables, and we will learn about the collision handling. So I was explaining about the chain and probe. So we will learn about this chain and probe. Hash tables. What is hash table? Based on the definition, hash table is a kind of structure, the data structure, that we can use to put all the information in a very limited space of storage. So let's see this one. You know already about the map. Intuitively, a map M supports the abstraction of using keys as indices, as index, with a syntax such as MK. So if I use mk means I want to check whether there exists key k or not. As a mental warm-up, consider a restricted setting in which a map with n items uses keys that are known to be integers, and it is in the range of 0 until n minus 1 for some n bigger than equals to n. Let's say I have determined my storage, and my storage will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my keys are not integer. So if the key is integer, it is easy. I can put, let's say the key is 6, then I can put in the index 6. I have the key equals to 5, then I can put into the index 5. But what about if the key equals to k? What is k? Then we need to convert the k into some kind of integer. If I have the key equals to half, what is half? Is it possible to put into one element in this map, or it is in the list like this one? So we need to change this into integer. After we change into integer, then we can put this half information as the key into one of the following lists. Because we know that every of this map or this list will need one integer index. So in the more general kinds of keys, what should we do if our keys are not integers in the range of 0 until n minus 1? There is one kind of function. We call it hash function. If you have any keys, the general keys, so any key, you can find the corresponding index. You can check the corresponding indices in a table. For instance, the last 4 digits in social security number. So this is an example from the US. Maybe in Korea, there can be another kind of HashTable. Your social security number, it is similar with the 등록증. You have 6 plus 7, 13 digits. Yeah. So in that, let's say I have this social security number, and then if I have the last digit is 1, then I will put it into the index 1. If I have the last digit is 2, I will put it in the index 2. If I have the last digit 4, I will put it in the index 4, and so on. So we can have a kind of functions. The function will be like mapping what you already have into integer. So this has function. It maps keys of a given type to integer in a fixed interval. So if you have like 0 until 10, then you will have like 0 until n minus 1. So it will be like 0 until 9. For example, we can have a function something like this, x mod n. X mod n, it means it is a hash function for integer keys. So this is just an example. If X is very big number, let's say if the big number like this one, 0 to 5, 6, 1, 2, 0, 0, 0, 1. And I want to mode with a number of n. Let's say if n is 10. Then what we can do is we convert this one 0 to 5, 6, 1, 2, 0, 0, 0, 1, and then modulus 10. And what is the result? Every number, when we do the modulus, we will get the remaining value. Okay? The remaining value, if it is ended by 1, then the remaining value will be 1. If it is ended with 2, the remaining value will be 2. Okay? So we will get the key only based on the last number. So this is one example. Actually, we can have a lot of hash function. So the integer x, it means after I have a function like this one, we call it the hash value of the key x. A hash table for a given key type consists of, if you have a hash table, it means I have a hash function. This is the hash function, it's, and I have an array, or we call it a table. Maybe, yeah, if I want to put like this one, like this table of a size of n. So when we have the number, the social security number, if we have until 10, okay, then I have 10 size. So if it is 10, then it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the meaning by the hash table. So in the hash table, there will be two kind of things. The first is the hash function, and the other is the array with the n size. When implementing a map with a hash table, the goal is to store the item k, o. K is the key, and then o is the object at the index I. What is I? I is the value from the hash function. HK is from the hash function, this one. So SSN is the social security number. We can design a hash table. The hash table for a map storing entries of SSN, name. So I'm going to design a map, and the map is containing key, which is the social security number, and the value is name. And this SSN, which is the social security number, is a 9-digit positive integer. Our hash table use an array of size n equals to 10,000. So it means there will be 10,000 elements in the array. Then the index will be 0 until 9999. Because as per the definition, we have 0 until n minus 1. I need to extend this up. Okay, it is better. Okay, and from 0 until n minus 1. So if I want to have the n equals to 10,000, then there will be an array from 0 until 9999. So this hash function, I want to use the hx, which is the function, to get the last 4 digits of x. So if I have this number 0, 2, 5, 6, 1, 2, 0, 0, 0, 1, modulus n. The n is 10,000. And what is the result? We have 4 digits of zeros. So it means the digit will be the last 4 digits for the remaining values. So the namoji, the remaining values will be the last 4 digits. So if it is like 20075199998, then if this number mod by 10,000, then the result will be 9998, and this can be inserted into the index 9998. Yeah, there can be another example. So this is an example. There is a bucket array of capacity 11. So if I have 11, it means I will have the index 0 until 10. Because n, the big N, is 11. And the number of array will be from 0 until n minus 1. So it will be from 0 until 10. Now I have some, elements. Now let's say I already have this element 1D, 25C, 3F, 14Z, 6A, 39C, and 7Q. So how can I put this into the bucket? So we will learn about this one. Now the idea is, if it is 1, it is easy. 1, it is the index 1. Okay. What about 25? 25, because we have the place is on the 11. Then 25 mod 11. What is 25 mod 11? It is 3. Then we will put the 25 into the index 3. 3, F. Okay, because we know 3, just put into the bucket number 3. 14Z. What is 14? 14, then it is more than 11. So you need to do the again with mod 11. Mod 14 mod 11, then it is 3. So we will put the 3 in the list, the index 3. 6, you can put in the 6. 39. So 39 mod 11. Then it is 6. So we put into the index 6. So the bucket will be something like this one. Okay. Now we are going to discuss about hash functions. Okay, before we discuss this hash function, I think it's better to have a break. Let's have a break. I will continue after the break.